Hello everyone, and welcome to today's lesson on 8.2 Confined Space Work. Before we begin today's lecture, I would like to share with you a real accident case. A few years ago, in a certain factory, a worker was assigned the task of cleaning a storage tank. Unfortunately, shortly after entering the tank, the worker lost contact. Although rescue personnel arrived quickly and carried out emergency rescue efforts, regrettably, by the time the worker was rescued, vital signs had ceased. Why would a storage tank take a life? And how can such accidents be prevented? Next, we will delve into the dangers and safety regulations of confined space work through a series of topics. First, let's understand the definition of a confined space. A confined space refers to a facility or area that has restricted entry and poor ventilation, and where there may be flammable or explosive, toxic or hazardous substances or oxygen deficiency, which poses a threat to the health and life safety of those entering, whether fully enclosed or semi-enclosed. Common confined spaces include reactors, towers, kettles, tanks, vessels, furnace chambers, boiler, drums, pipelines, as well as basements, manholes, pits or pools, and utility trenches. Confined space work possesses multiple hazardous characteristics. Among these, poor gas environment is one of the main hazards. Hazardous chemicals may accumulate to form high concentrations of toxic gases, leading to poisoning and asphyxiation accidents. In addition, material stacking, difficulties in rescue, and other hazards are also issues that cannot be ignored in confined space work. In the case study mentioned earlier, the worker's death was caused by poisoning. Therefore, we must adopt strict safety measures to ensure work safety. Next, we will focus on the safety measures and requirements for confined space work. First, we must implement energy isolation. This is the first line of defense in confined space work. We must ensure that any pipelines or electrical connections linking the confined space with other systems are effectively isolated to prevent the release of hazardous energy such as electrical, chemical, thermal, or pressure potential energy that could cause accidents. In addition to using valves to cut off flow, we must also use methods such as blind plates or removing pipelines and installing blind flanges to achieve safe isolation. Moreover, when the confined space contains electrically powered equipment, such as agitators, we should disconnect the power after shutdown and apply lockout and tagout to ensure that nothing is left to chance before commencing confined space work. We must evacuate all materials from equipment and pipeline systems, and according to the characteristics of the materials previously contained in the confined space, perform cleaning, boiling, or replacement of the confined space. This is to ensure that no harmful substances remain in the confined space, thus preventing hazards, thus poisoning or asphyxiation to the workers. The purpose of ventilation is to ensure air circulation within the confined space, which is one of the key safety measures in confined space work. We should open manholes, handholds, material access points, air vents, smoke vents, and other facilities that communicate with the atmosphere to allow natural ventilation. If necessary, forced ventilation may also be employed, but it must be noted that pure oxygen or oxygen-enriched air must not be introduced into the confined space to prevent the risk of explosion or other hazards due to excessively high oxygen concentrations. Gas monitoring is a critical component of confined space work. Before work begins, We must conduct gas sampling and analysis within the confined space to ensure that the oxygen content, allowable concentrations of toxic substances, and concentrations of combustible gases meet safe requirements. Specifically, the oxygen content should generally be between 19.5% to 21%, and in oxygen-enriched environments, it must not exceed 23.5%. The allowable concentration of toxic substances should meet relevant standards. When the lower explosive limit LEL of the measured gas or vapor is greater than or equal to 4%, its concentration should not exceed 0.5%. And when the LEL is less than 4%, its concentration should not exceed 0.2%. During gas monitoring, the following points must also be adhered to. Sampling personnel must take adequate personal protective measures and conduct gas sampling and analysis within 30 minutes prior to work. Sampling points should be representative. Especially in larger spaces, multiple sampling points are required. During work, personnel should carry portable gas detection and alarm devices to continuously monitor gas concentrations. If work is interrupted for more than 60 minutes, monitoring and analysis must be repeated to ensure that the gas concentrations within the confined space remain within the safe range. In terms of personal protection, appropriate protective equipment should be selected based on the environmental conditions within the confined space. For example, in oxygen-deficient or toxic environments, one should wear self-contained breathing apparatus. In flammable or explosive environments, one should wear anti-static work clothing and work shoes. Use explosion-proof, low-voltage lighting and non-sparking tools. And in corrosive environments, such as those with acids or alkalis, wear acid and alkali-resistant work clothing, work shoes, gloves, etc. Regarding work supervision, a dedicated supervisor must be assigned. And in high-risk confined space work, additional supervisors should be assigned. The supervisor should continuously monitor from outside the confined space and must not leave their post to ensure the safety of the workers. At the same time, a record must be made of the personnel entering the confined space and the types and quantities of tools and equipment they carry, and a recount should be conducted after work is completed. Prior to confined space work, a hazard analysis must be conducted, and a confined space safety work permit must be processed in accordance with the work permit procedure. Safety warning signs must also be installed, and emergency equipment such as breathing apparatuses, rescue tripods, firefighting equipment, and first aid kits. We have now understood the safety measures for confined space work, and next we will learn the general procedures for confined space work together. Before work begins, a job hazard analysis (JHA) must be conducted, which is crucial as it helps us identify potential hazards during the work process. Then, in response to these hazards, carry out a series of safety preparations, including energy, isolation, material evacuation, and gas monitoring to ensure the safety of the work environment. Once entering the work phase, we must possess a confined space safety work permit, which serves as a pass for the work. During the work process, a dedicated supervisor must be assigned to monitor, who will supervise the entire work process. To ensure the safety of the workers after work is completed, conduct a thorough check and organization so that no safety hazards remain. To help everyone understand the entire process of confined space work, More intuitively, we will present a complete confined space work case through a video. Please watch carefully to deepen your understanding.
In the maintenance of equipment in the refining and petrochemical industry, power industry, and urban underground infrastructure operations, confined space operations account for a very high proportion. A confined space refers to a closed or semi-closed place such as towers, tanks, pipelines, sinking pools, sewers, etc., where access is restricted and flammable, explosive, toxic, and harmful substances may exist or oxygen deficiency may occur. In recent years, due to frequent casualties such as asphyxiation poisoning, fire explosions, falls from heights, electric shocks, and mechanical injuries in confined space operations, it has been revealed that enterprises with accidents have problems such as lack of management systems, unclear risk identification, weak safety awareness, insufficient skill training, and incomplete protective equipment for confined space operations. In order to learn from accident lessons and prevent potential hazards, we take the cleaning operation of the process water storage tank in the confined space practical operation base as an example, to demonstrate the standard confined space operation process and related safety precautions. First, before the operation, the Confined Space Operation Application Unit must carry out JSA, Job Safety Analysis, with the construction unit for the operation content, implement safety measures at the operation site, and jointly complete the JSA record form. Second, use blind plates to rigidly isolate the material sources entering and exiting the process water storage tank, and establish a blind plate isolation list for tank cleaning operations. Third, fully open the bottom drain valve of the storage tank to drain all process water materials in the storage tank. Fourth, open the manholes strictly in sequence. First open the manhole on the tank top, then the middle manhole, and finally the lower manhole. Fifth, after 8 hours of natural ventilation, use a professional gas sampler to sample the storage tank. Before sampling, it is necessary to confirm that the airtightness of the sampler and its auxiliary devices is intact by adjusting the length of the gas sampling rod and following the standard sampling operation procedures. Ensure that the gas inside the storage tank is collected, and then sequentially sample the upper, middle, and lower parts of the storage tank. Sixth, send the collected gas samples from the storage tank to the analysis laboratory for gas chromatograph analysis, and then record the analysis results of oxygen content, hydrogen sulfide content, and total hydrocarbon content. Seventh, if the analysis of the storage tank gas is unqualified, blow air into the lower manhole of the storage tank. Reduce the concentration of harmful gases in the storage tank through forced ventilation, and make the oxygen content qualified. After 2 hours of forced ventilation, carry out gas sampling and analysis again according to the above procedures. Eighth, if the gas analysis in the storage tank is qualified, issue a confined space work permit according to the system. The confined space work permit is jointly signed by the applicant, operator, supervisor, gas detection personnel, safety management personnel, etc. Ninth, operators, supervisors, and safety management personnel go to the site with the confined space work permit to prepare for entering the tank. Operators must wear safety helmets, work gloves, filter respirators, tool kits, low-voltage explosion-proof lighting equipment, explosion-proof walkie-talkies, hydrogen sulfide and combustible gas alarm instruments, fasten a life safety rope around the waist, and fill in the tool in or out tank record list and personnel in or out tank registration form. 10th, before operators enter the storage tank for operation. Set up warning fences or warning tapes at the operation site. And equip emergency rescue facilities such as fire extinguishers, positive pressure air respirators, and first aid kits. 11th, when operators enter the storage tank for operation, they should always pay attention to the hydrogen sulfide and combustible gas alarm instruments. If the alarm instrument sounds an alarm during the operation, the operator must immediately terminate the operation and exit the storage tank. 12th, during the operation of the operator in the storage tank, the supervisor outside the tank is strictly prohibited from leaving the supervision site. The supervisor must communicate with the operator every 2 minutes through an explosion-proof walkie-talkie. Pull the life safety rope twice every 2 minutes. And the operator must also respond to the pull of the life safety rope. Through the above interactions, ensure the safety of the operator and gain rescue time. 13th, within 2 hours of the operation, the storage tank must be sampled and analyzed for gas again. If the result is unqualified, the operation must be terminated immediately. 14th, during the cleaning operation of the storage tank, although the internal gas is qualified, when there is a strong odor or irritating smell, the operator must switch to a long tube respirator. That is, the operator breathes fresh air outside the tank. 15th, at the end of the confined space operation for tank cleaning, it is necessary to count the operators and tools entering the tank to ensure that there are no personnel or tools in the tank, and then close the manhole with a tank manhole lock and hang a no entry warning sign. 16th, finally, the safety supervisor signs and confirms in the completion column of the confined space work permit. 17th, enterprises with conditions should implement video monitoring for the entire confined space operation. Through the video demonstration, we have understood the definition, risk identification, work process, safety measures, and responsibilities of relevant personnel for confined space operations. Please keep the standard process of confined space operations in mind and skillfully apply it in practical work. I wish you all a smooth and safe completion of all confined space operations.
Through this lesson, we have gained a comprehensive understanding of the safety management knowledge for confined space work. I hope that everyone can apply the knowledge learned to practical work to ensure that each instance of confined space work is carried out safely and efficiently.